All right, new lesson. This lesson pertains to the normal distribution. We just completed a brief introduction to probability in the previous lesson, or maybe at least the previous video. And it lends nicely into the normal distribution. I wish we could spend more time on probability, but in a class of this nature, we just don't have the time. And it's not really the focus. Applied statistical techniques and procedures are the focus. So again, starting normal distributions, a specific type of normal distribution that I want to begin with is called a standard normal distribution. Now, let's pump the brakes a little bit and kind of think where we are and what we're doing. The goal of statistics in general is to do what? It's to take a sample from a population. Again, our population is very, 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 very large. Lots and lots and lots of people, subjects, elements, dogs, cats, trees, whatever it may be. So we take a sample from our population and we use that sample data to make an inference about or an estimate of an unknown population. So in statistics, we constantly have this struggle, dilemma, dynamic, if you will, between samples and populations. So this is starting to get serious now, all right? So we need to be able to distinguish the difference between when measurements are taken in a sample and when measurements are taken in a population. Well, we have different notation that you need to kind of tattoo to the brain. If we have a mean, if it comes from a sample, the notation we use is X bar. If we have a mean from a population, the notation we use is mu. You'll notice that all of the population notations are Greek letters and the samples are not. So the standard deviation for a sample, usually like SX or just S, could be just S, but the population standard deviation is sigma. And the variance, of course, is just the standard deviation squared. So whichever we use there, we just square it. So normal distributions describe populations. It drives me absolutely insane when people go out and they get sample data and they create a histogram and they get a histogram that's like bell-shaped and symmetric, and they say that my sample is normally distributed. No, it's not. Please stop them. I'm actually preaching to my master's and my doctoral students, not you. But let's just get started off on the right foot. Sample data is not normally distributed. It may be bell-shaped and symmetric. It may have some properties that make us think of normal distributions, but it's not normally distributed. We can't get a normal distribution until we reside in a measurement from a population. All right, so we're going to study normal distributions, but we're going to begin the study with looking at examining something called a standard normal distribution. Now, a standard normal distribution, again, is a specific type of normal distribution that has mean 0, standard deviation 1. In a normal distribution, whether it's a standard normal distribution or just a regular normal distribution, the mean always resides right in the center. So when you're given this bell-shaped and symmetric curve, whatever value is smack dab in the middle, that's the mean. When you're tracing a normal distribution, you'll find that there's this spot right about here, going to about right here, where the line is about straight. Now, we call that an inflection point if you get into calculus stuff. Don't worry about that, but there's a straight line right there. If you'll come to the center of the straight line and drop your line down, that is where one standard deviation above the mean is defined to be. Now, let's just say, and this is probably a good time. Let me sketch something out. I wasn't going to do that in this. Okay, let's just sketch this out. Again, rough draft. What would the mean be? Well, the distribution is centered at 30, so the mean will be equal to 30. What would be the standard deviation? Well, when I come over here and I see this part right here is almost a straight line. I would come to the center of it, drop a vertical line down. The standard deviation would be the difference between that and that. So I'd say that's about a 39. It's just a little shy of 40. So I would say that the standard deviation would be, 8 or 9, something like that. More about that later, but I just want that to be something that's kind of on your radar uh, right away. Now, the formula for the normal distribution is quite messy. And luckily, we don't mess with this stuff in a class of this nature. We use technology. Now, a very important thing to keep in mind, again, tattoo this into the brain, the total area under the curve, not to be confused with the standard deviation. The total area under this curve is equal to 1 square unit. Okay? And another thing, the standard normal distribution is just a distribution of a population of z-scores. Now, what kind of problems are we going to be working here? I've laid out a couple of problems that we're going to have on our agenda. And wait a minute, that's not what I want. I want this one. So the first goal is going to be able to find probabilities when given a z-score. So I have 3 examples here that I want to run through and just show you just how easy this can be if you'll let me teach you something. Now, let me pump the brakes and put that in proper context. A lot of you, when you took maybe a statistics course in high school, you used tables. I don't use tables. Tables are archaic to me. That's kind of like driving to Detroit tonight and taking a horse and buggy. I'm not going to take a horse and buggy. I'm going to take my car. I'm going to have my phone, Bluetooth in. Yeah. I'm going to use MapQuest. I'm going to use the the equipment, let's put it this way, that is appropriate for the day. Tables were appropriate back in the 60s. So if your high school teacher taught you tables, then I'm going to do everything I can to keep you from using tables. Why? Because first of all, technology is better, it's more accurate, and it is easier if you will let me teach it to you. So come to me with an open mind and let me teach that. So probability is equivalent to shaded area. So the first problem I want to look at is we have a z-score of 1.28. What's the probability of selecting something above it? Well, that's just going to be equivalent to the shaded area. How much area is shaded there? Below 0.56, that's going to be the area to the left, below, less than. If I can find that cumulative area, that is equivalent to the probability. And then sometimes we get into between two values. Negative 0.60 to 1.5. What's the area between those two values in a standard normal distribution? Well, that's equivalent to randomly selecting an object and a measurement and it being between these two values. It turns out this is super, super easy to do. If you will let me teach it to you, you might say, why is he being so redundant and so forceful about this? Because I see class after class after class, the people who get these questions right are the ones that let me teach them something. The ones that continue to struggle are the ones that struggle or the ones that shut down and keep wanting to use those stupid tables ineffectively, by the way. So, really cool. Go to STAT, go to calculator, and what are we studying right now? We're studying the standard normal distribution, which is a subset, if you will, a specific type of the normal distribution. When I get there, I've got this picture. For the standard normal distribution, the mean is equal to 0, so I want a 0 there. The standard deviation is equal to 1. Now I'm going to create my picture that I need. What do I need? I need above. Above what? 1.28. Compute. I've got my answer. 0.1003. Now, can you imagine, if you know anything about this stupid tables, can you imagine how long it would take to get something like that in a table? Plus, you always have to worry about, well, am I getting above? Am I getting below? If I subtracted it from one correctly? In this way, I've got a visual. I have a visual of the standard normal distribution, mean 0, standard deviation 1, and the area that's shaded in red that corresponds to what I want. All right, below 0.56. Mean 0, standard deviation 1, I want below. 0.56, there's my answer, 0.7123. Well, what if I want between? Well, right up here, you can see there's a between button that works very similar to the standard normal calculator function. Still, mean 0, standard deviation 1. My left value is negative 0.6. My right value is 1.5. My answer is 0.6589. You got to admit, if you came into a calculus, daggone it, if you came into a statistics class, this is all calculus. You just don't have to do the integration part. If you came into a calculus, or, daggone it, if you came into a statistics class and think statistics is just really hard, I've heard it is. Everybody tells me it's hard. You got to admit, this is extremely, extremely doable. You should be successful at it. Now, let's change the goal just a little bit and look at these problems. Now, these problems are different because we want to find the z-score, not the probability as we did over here. We want to find the z-score that has 70% of the scores below it. Well, because the middle line here, the mean, separates the distribution into two equal parts, I know that 50% of the distribution is below the mean, right? I know that. Just a little bit of injecting a little bit of common sense there. So I know to get 70% that this z-score has to be to the right, right? Has to be bigger. The line has to be to the right because the area is bigger than 50%. So I have to move this way. Well, finding it's easy. 0, 1. I need below or above, right? So I need that to be below. But I need my area, not the z-score, to be 70%. So the z-score that has 70% below it is 0.52. All right, 32% above, for obvious reasons. For obvious reasons, 0.47. Sometimes we, almost said sometimes in calculus, again, you have to understand this is all calculus, but we don't worry about that. We let technology take care of that stuff for us. Sometimes in statistics, we need to find the z-score, in other words, the negative of it and the positive of it. Again, this line right here is 0, right? That's the mean. So any number to the left of 0 has to be negative, and any number to the right of 0 has to be positive. So sometimes in statistics, we need to find the negative z-score and the positive z-score that has a certain percentage between it, namely 95%, 99%, 90% for reasons I'll explain later in the class. But let's say we want to find the one that has 40% between it. Well, it should make a little bit of sense that we go to between. We have 0 and 1, again, the standard deviation. The area I need is 0.40. Remember, never use the percentage in calculation. 0.40, so the difference is negative 0.52. and positive 0.52. I hope you find this as easy as I think it is for you to learn. Again, just generally speaking, get rid of your tables. Those tables are uh, just goofy. I mean, they're hard to use. They don't give you precise answers. When you're done, you don't have a visual of the phenomena that you're trying to model. Um, so just let me teach you something here, please. I beg you. All right, take care.